Welcome to week 6. And this week we're going to talk about machine learning in Python. So primarily the library which people will use for machine learning is the scikit-learn library. And so I'm going to walk you through a couple of pieces of this and give you a demonstration code example too as well. So scikit-learn is scikit-learn.org is the main website. And because this topic can be quite broad and quite challenging to learn all the individual pieces of it, I wanted to make sure I start with kind of showing you the website. And so here's the website right here. As with the other libraries, in order to install, you'll do a pip install. Now this one here is scikit-learn. If you do the /u right here, you'll make sure that you'll update if it's already there. And you can also use this little check script right here to make sure that it's working. Now the really cool thing about this website is if you're going to try a specific type of model, such as if we're going to do a regression model, for instance, you can go in here and you can see individual examples of all different kinds of regression models. Let's just say we're going to do an ordinary least square. Here it gives you a code example of how you can do that. So the next thing I'm going to show you, so that's the website right here, scikit-learn.org. The next thing I'm going to show you is the cheat sheet. So remember we talked about this. This is included, and it's actually the last in the cheat sheet set here, right here. This was again by DataCamp. Here it gives you an example of how you can do all of the various types. Again, some of the more common ones here, the linear regression, the SVM, the naive Bayes, and the k-nearest neighbor, for instance, right here. Here's how you do k-means, and here's how you do principal component analysis. So you see it's relatively straightforward. Now this is going to come into play when you start doing your assignment for this week. Wanted to point you at least to that so you can see these examples of all of those individual pieces. But here's another really interesting thing that they've included in the cheat sheet, and that's kind of a workflow here to show you which technique you would want to try to choose. So let's start here, and let's say the first question it asks is, do you have greater than 50 samples? If you don't, in order to use this, you really need to get more data. You don't have enough data in order to use for one of these techniques. So then let's say the next question is, are you predicting a category? So let's say no, I'm not predicting a category. Then I would fall down into this right here. Am I predicting a quantity? So let's say, yes, I am predicting a quantity. And then it's going to ask the next question, do I have more than 50 samples but less than 100,000 samples? If the answer is no, then I would go up here, and this would be an SGD regressor, would be the appropriate one. So helping you kind of choose which of these techniques, I think that this is a good thing to have kind of handy in your toolkit too as well. This will come into play when you start working on your final assignment, your final project, because for that you're going to have to create yourself a data science project, and you may decide that yes, this is going to be appropriate, that you'd want to use scikit-learn, and so this will kind of help you choose the right technique, or at least get you in the ballpark for the right technique for what you're going to use for that. So that's the cheat sheet. So let's go to the demonstration script. And so again, at this point here, we're assuming that we have scikit-learn. The objective here is to give you some practical experience into some basic machine learning algorithms. I'm going to show you 4 different kinds here. I'm going to show you decision trees. I'm going to show you k-nearest neighbors. I'm going to show you a linear regression. And I'm going to show you a naive Bayes as well. So for each of these, we're going to load a data set, and I'm going to use just example data sets that are included with scikit-learn so you can reproduce them relatively easy yourself. Split the data set into a training and testing set. So with other classes you may have had on data science, you know that the good practice is to train your model on a subset of the data. Then you can determine the accuracy. You can go through training iterations, then have a testing data set that's a separate data set that you can use. And by using this, by using a training data set, you can tune your model, create your model, tune your model, and then use the testing data set to validate the model. So we're going to do that in these examples here too as well. In the first case, I'm going to use a decision tree. I'm going to make a decision tree classifier, and I'm going to use a maximum depth of 2 and fit it into the training data. And then I'm going to evaluate the performance of that tree classifier using the data accuracy as mentioned kind of in that technique. K nearest neighbor is going to be the next one which we'll work on. We're going to use the breast cancer data set from scikit-learn. We're going to look for our K nearest neighbor classifier, K equals 5, and fit that into the training data, and then turn around and look for the precision of that, and as well as the F1 score to evaluate it. Third one, we're going to revisit the California housing data set. We're going to load that in and split it into the training and testing again. We're going to implement a simple linear regression and fit that into the training data, and then we're going to evaluate that using the mean squared error as the evaluation method. And then finally, the SMS spam collection data set from scikit-learn. We're going to load that. We're going to split it into training and testing. And then we're going to implement a naive Bayes classifier and validate that using accuracy, precision, recall, and the F1 score. So the deliverables for what I'm going to show you here, it's the Python file, the Jupyter Notebook, and a text file of any outputs or inputs that I would want to use inside of it. We're going to have the exact same grading criteria that we had before. So let's get right into it. First of all, I'm going to go ahead and fetch the data set, and we're going to use the fetch California housing. So this is very similar to what you've seen in the previous ones. And I'm going to extract the feature and target vectors. I'm going to extract the data and the target from that and store those in X and Y. So that's something that I'm going to use throughout the notebook. I'm going to load other data sets here. Here's the breast cancer data set. Here's the iris data set. Here's the SMS data set. So let's use the first one. I'm going to do a decision tree right here. I'm going to do my imports. So I'm going to use a couple of things here. First of all, I'm going to use matplotlib to do a plot. I'm going to use NumPy in order to do the numeric calculations. I'm going to use the scikit datasets. I'm going to use feature extraction text to do the count vectorizer. I'm going to employ the train and test splitter, which we're going to use train and test splitter throughout this. I'm going to use the decision tree classifier part, and I'm going to import accuracy score, precision score, recall score, and F1 score. I'm going to import those as part of this. So the first one here, I'm going to do my fetch. I'm going to set the SMS equal to the fetch, and that's just pulling it out of the scikit-learn datasets. I'm going to then turn around and convert the text data to numerical features using count vectorizer. So this is our first implementation using something that's going to go to the natural language processing. Now in future weeks, we're going to do some more detailed dive into natural language processing using NLTK, but this is again a very simple one, just so that I can vectorize and pull out the text data to get the numerical features. I'm going to fit a transform using the SMS data that I pulled out here. And then I'm going to set the X and Y, so that's what I'm going to use for the target. I'm going to say if the target does not equal 0, then change it to the type of integer. Then here is the standard train test split call. So X train, X test, Y train, Y test. That's going to split both an X and a Y set into a train and a test data set. I'm using X and Y from the vector that I pulled out up here. I'm going to set some parameters too as well. So random state and the test size. That's going to determine which records are selected inside that test train split. So that's going to be a common type of call that you would do with that. I'm going to do a decision tree classifier right here by using the decision tree classifier. I'm going to set the max depth. And you can see here's all the individual potential parameters that I could throw to decision tree classifier. I'm going to set the max depth to 2 as discussed, and the random state to 42. I'm going to then turn around and run the fit. And then I'm going to turn around and evaluate the performance of it. So first of all, I'm going to create one called yPredict using the predict function. I'm going to determine the accuracy score. I'm going to do the precision score, the recall score, and the F1 score. And then I'm going to turn around and I'm going to print those off just using a standard print statement and some regular expression in order to just do some formatting of it, just so that it looks nice. The next thing I'm going to do is, this is again optional, but I want to go ahead and just put a bar plot as well to look at those evaluation metrics to make it easy for me to read. So here we're just going to use the matplotlib, the plot functions, doing a bar chart, setting a Y limit, putting a classification title on top of it, and then doing a show. Now this takes about a minute to run, almost 2 minutes sometimes, depending on your system. My system here, it's just under a minute it takes to run. And we can see here by the accuracy, the precision, the recall, and the F1 score. Those are the precision metrics. Now again, visually, I presented this here in a graph just so that we can see where that looks like. And so here's just kind of talking through the steps which I just went through in order to implement this. Okay, so that's the first example. Now the second thing we're going to go through is the k-nearest neighbor. In this case here, I'm going to use the iris dataset. Again, continuing to use very much the same type of a setup. Now I'm going to use the k-neighbors classifier. That's the function that I'm going to pull out from scikit-learn. And I'm going to use the load iris. I'm going to use the iris dataset in order to do it. Here we see it's the exact same type of train test split. Here's the call to the k-nearest neighbor. And I'm going to set it to 5 nearest neighbors. And then we do the fit call. The fit call actually runs the process. Then turning around, doing a Y predict, precision, recall, and F1 score, printing those out. And then doing a plot too as well. Now in this plot here, I'm going to do a scatter plot showing the Y test and the Y predict. I'm then going to turn around and do a normal plot, set an actual and predicted and k-nearest neighbors just for some titling to make it look pretty, and then do a show. So here we see the precision, the recall, and the F1 score. So visually we can see the k-nearest neighbor. Next, we're going to do a linear regression. So here we're going to load the iris data set. We're going to split that. So again, the same type of a setup as we've seen before. Load an iris, and then here we're going to do the train test split. And then we're going to do a linear regression. So that's the linear regression call right there. I'm going to go ahead and fit it using the training data set. I'm going to then turn around and do the prediction, evaluate the performance against the test data set. I'm going to calculate the mean squared error by using the mean squared error function. Print that out. And then I'm going to do, again, a similar type plot, showing a scatter plot, showing the Y test versus the Y predicted, and then do a normal plot, and then do the actual and show that. And this is the result. Finally, the naive Bayes. Same type of a setup here, but again, we're going to import Gaussian MB for the naive Bayes, loading the iris data set, setting the iris data set up here as the split. There's the naive Bayes call. There's the fit. We're going to go through again the evaluation. So we're going to do very similar to what you've seen before here. We're doing a predict, an accuracy score, a precision score, a recall score, and an F1 score, printing those out. And then I'm going to also do a graph to show the graph here too as well. And I didn't run that one. Let me run that one real quick. And here is the classifier right here. So that gives an example of the 4 techniques here. So for your job, we're going to use the iris data set. We're going to use the breast cancer data set, the California housing data set, and the spam data set. And so I gave you the loads in that initial demonstration up here. To help you out in these loading of the data sets, you'll see that there's various data sets that are loaded here. I've also loaded another one in there too as well, just for you to kind of look at. But these would be all the data sets which you're going to be looking for here. and you're going to do a decision tree, a k-nearest neighbor, a linear regression, and a naive Bayes. So basically the same ones that you've seen. And you'll notice that these are different data sets than what I used for the example, but you at least have an example of how to do it. And now it's your turn to turn around and build one of those for yourself. If you include the graph or you don't include the graph, either way would be fine, as long as the performance metrics are there and you can talk about the performance metrics. So everything that you'll return will be in this Jupyter notebook. And that matches back to the 4 questions. So make sure that all the instructions are followed. Make sure that the code is as efficient as you can get it. You can see from our demonstration script, actually doing a prediction, you can get that all within one screen. It's relatively straightforward. So I don't imagine this is going to cause too many headaches, but the very first time working through some machine learning inside of Python can be a bit intimidating. I understand that. So if you have any questions, as always, reach out to the instructor, reach out on the discussion boards. And also, if you really get stuck, send an email and your instructor will respond back to that as well. So that's pretty much the assignment for this week. If you have any questions, please reach out. Have a good one. Thank you.